Hi, Mr. Richards here, and today's algebra lesson is on substitution. Our objective is to solve systems of equations by using substitution and to solve real-world problems involving systems of equations by using substitution. Our previous lesson had us solving systems of equations by graphing. This time we're going to solve these by using an algebraic method called substitution. And there's 3 steps. Our first step is, when necessary, solve at least one equation for one variable. Either solve an equation for x or solve it for y. Because then, in step 2, we're going to substitute, why this method is called substitution, substitute the resulting expression from step 1 into the other equation to replace the variable. Then solve the equation. In step 3, you'll have an answer in step 2. So in step 3 is to substitute the value from step 2 into either equation and solve for the other variable. Write the solution, if any that is, as an ordered pair. And these steps will make sense as we start to solve these problems. Use substitution to solve the system of equations. Now we're not going to be graphing these here today. We have y equals negative 4x plus 12 and 2x plus y equals 2. Well, here step 1, remember, was when necessary solve at least one equation for one variable. Well, we're given y equals negative 4x plus 12. It's pretty hard to solve for one of the variables if you have 2 variables. So what we're going to do here, if we can picture it this way, we have y equals negative 4x plus 12. And then our other equation was 2x plus y equals 2. What we're going to do in this substitution method is to take this negative 4x plus 12, which is y, and plug it in for this y. Why do we do that? Well, if you were to do that, we have 2x, and then again, bring down the negative 4x plus 12. We're going to substitute that in for this y equals 2. What this allows us to do now is to solve for x. It allows us to solve for a single variable. So if we simplify this, 2x minus 4x is negative 2x plus 12 equals 2. Subtract 12 from both sides. And negative 2x equals negative 10. Divide by negative 2 on both sides, and you get x equals 5. We're able to solve for a single variable. Now, that was step 2. What we can do now in step 3 is to take either equation. either the y equals negative 4x plus 12 or the 2x plus y equals 2, and put in our x. So I'm going to, you could use either, I'm going to take our y equals negative 4x plus 12. Again, you can use either. And I'm going to put in the 5 for x. So y equals negative 4 times 5 plus 12. Negative 4 times 5 is negative 20 plus 12, and y equals negative 8. So just like that, I have an x and I have a y. And my final part of step 3 is to write this as an ordered pair, where ordered pairs are x, y, so my answer is 5, negative 8. So what did we do here? Well, we were given y equals, so we put that in for that y right here. We solved for the x. We put this x into one of the two equations. You can choose either. You'll find out what y is. So you know what x is, you know what y is, so you have your ordered pair that is the solution to this system of equations. Pretty cool. Now, we have to solve then substitute here, as it says right here in our handy little note. So let's take either equation. I'm going to pick the first one. So step 1 here is to take this x minus 2y equals negative 3 and either solve for x or y. Well, I think it's pretty easy to solve for x here, because if I add 2y to both sides, I can get my x isolated, I can get it alone. X equals 2y minus 3. Because now what I can do is to go into step 2 is to take the other equation, 3x plus 5y equals 24. What I can do is to take this 2y minus 3 that I'm calling x and putting it in for x. So then I have 3 times the quantity 2y minus 3 plus 5y equals 24. And if this looks like a distributive property question, you'd be right, it is. We have 3 times 2y is 6y, minus 3 times 3 is 9, plus 5y equals 24. We can combine our 6y and our plus 5y on the same side of the equation to 11y minus 9 equals 24. Add the 9 to both sides. 11y equals 33. I'm just going to write this up here. Give myself a little more room. Divide by 11 on both sides. And y equals 3. So I've finished step 2. I've solved for a variable. Now, step 3, take either equation, and I think this x minus 2y equals negative 3 looks easier to solve. I don't know if it is, but it looks easier to solve. I'm going to put in the 3 for y so I can solve for x. So x minus 2 times 3 equals negative 3. X minus 6 equals negative 3. Add 6 to both sides, and x equals 3. Interesting. So my ordered pair, my x goes first is 3. My y then is also 3. Pretty hard to get that order mixed up. So it's 3, 3. But if we review what we've done here, step 1 was to solve one of these two equations for a single variable. And I picked the first one because I knew all I had to do by looking at this was move this minus 2y over. The other one I would have had to move and then divide. I think just simply moving is easier. So x equals 2y minus 3. I took that 2y minus 3, put it in for an x. Then I simplified, I combined like terms, I solved a two-step equation to get y equals 3. once I have what one of these is, you can pick either equation and get your answer, x equals 3. Lastly, rewrite this as an ordered pair, x first, then y. Again, numbers were the same, so it didn't really matter here. 3, 3. Now, we get into examples just like you had graphs that had no solutions or infinite number of solutions. We also have those with substitution as well. So we have 2x plus 2y equals 8 and x plus y equals negative 2. And we'll again use substitution here to solve. So step 1, let's take our x plus y equals negative 2 and solve for that x. We'll subtract y from both sides. And we'll get x equals negative y minus 2. So then in step 2, we can take the other equation, 2x plus 2y equals 8, and substitute in for the x 2 times negative y minus 2 plus 2y equals 8. 2 times negative y is negative 2y plus 4 plus 2y equals 8. And as we look to combine like terms here, we have our negative 2y and our plus 2y. Well, those just go away. Negative 2 plus 2 is 0. So we're left with 4 equals 8. Well, 4 doesn't equal 8. That's not true. So that means there's actually now no solution to this graph, to this system of equations. No solution. Now if we use substitution to solve this systems of equations, again, if I have x plus y equals 1, let's make this simple. Let's subtract y from both sides to solve for x again. X equals negative y plus 1. So that in step 2 now, I can take my other equation, 3y plus 3x equals 3. I can substitute in for the x, so I'll have 3y plus 3 times negative y plus 1 equals 3. Distribute, so you have 3y plus a negative 3y plus 3 equals 3. Because again, I took, not to go too fast here, but 3 times negative y was the negative 3y, and 3 times 1 was the 3. And then to combine like terms, 3y with the negative 3y, that just cancels out, and I'm left with 3 equals 3. Well, that's true. 3 does equal 3. So in this case, I have an infinite number of solutions. So again, similar to the last example, except the last example we had, what, 4 equals 8? Something like that. And that wasn't true. So there were no solutions. Here, you get 3 equals 3, and our variables kind of just disappeared. And so we have infinite number of solutions. Now, a nature center charges $35.25 for a yearly membership and $6.25 for single admission. Last week, it sold a combined total of 50 yearly memberships and a single admissions for $660.50. How many memberships and how many single admissions were sold? Well, we can use a table to help set us up to solve a systems of equations question. For the numbers sold first, let's say that the number of yearly memberships sold were M. We don't know yet. Let's say that the number of single admissions were A. But we do know that it added up to be a total of 50. We know that the sales for the yearly memberships can be represented by $35.25 times M. That represents the total number of sales of the memberships. We know that single admissions were $6.25. and that's going to be times the number of admissions A. And we know that the total sales was $660.50. So using that, we can write two different equations. We can say the numbers sold, we have M plus A, our yearly memberships plus our admissions. Well, it was a combined total of 50. So somehow our whatever the M is plus whatever the A is going to equal 50. And then with the total sales, we have an equation of $35.25 M plus $6.25 times the single admissions is going to equal total sales of $660.50. So we have that as our systems of equations. Again, just to look at the table, M plus A, yearly plus single admissions, equaled a combined total of 50. That's where the top row comes in. The bottom row represents our total sales. Well, $35.25 per yearly membership plus $6.25 per single admission was a total last week of $660.50. Now, once we have that, we can solve this equation. So step one. Let's take M plus A equals 50 and solve it for one of the variables. Let's just solve it for A. Let's subtract M from both sides. And A is going to equal 50 minus M. Now, for step two, let's take our second equation, 3525M plus 625A equals 660.50 cents. We're going to substitute in, we have A equals 50 minus M, we're going to put that in for A here. So 3525M plus $6.25 times 50 minus M is going to equal $660.50. We're going to use the distributive property here. So we'll have $35.25 M plus $6.25 times 50 is $312.50 minus 625M equals 660.50. Lots of fun math here. We can combine the like terms here. We can combine our M's. 3525 minus 625 is going to get us 29M plus 312.50 equals 660.50. And now solve the equation. Subtract 312.50 from both sides. Then you're left with 29M equals, and that subtracts out to 348. Then divide by 29 on both sides. And M equals 12. Now, you're not done yet. You've solved that the memberships, the yearly memberships, are 12. What about the single admissions? Well, we'll come over here for step 3. Let's use our easy equation. M plus A equals 50. We know that M is 12. So we're going to put 12 in for M. 12 plus A equals 50. Now we can subtract 12 from both sides, a much easier equation to solve. And A is going to equal 38. Now, in our other questions, we've been answering these as ordered pairs. We're not graphing this one. So we can just write as our answer in words, we have 12 yearly memberships and 38 single admissions. And that's it. A long process, but one you can do. Just a more complicated system. And that's it for this lesson. Good luck.